Today we are looking at problem 19 of the MIT Integration Book of Fire Exam 2016, which is the indefinite integral of 1 over 1 minus x plus x squared minus x cubed. This is actually fairly easy, but let's see how we may be able to solve it. 1 over 1 minus x plus x squared minus x cubed. We could try and factorize the denominator. So this is 1 minus x, and then let's pull x squared from x squared minus x cubed out so that we're left with 1 minus x here. So what we see is we have these two common 1 minus x's, so let's pull that out. And so we have 1 minus x, 1 plus x squared. So let's express this fraction into a partial fraction format. So 1 minus x times 1 plus x squared can be expressed as a fraction that has a constant a over 1 minus x and then a constant b times x plus c over 1 plus x squared. So we have to assume b exists, and then eventually we'll prove that it doesn't. So let's it doesn't, or it does exist. So let's go ahead and multiply 1 times x, 1 minus x across, so that we get 1 plus x squared being equal to a plus bx plus c over 1 plus x, 1 minus x. If we assume x is 1, we definitely see that this part goes to 0. So this entire enterprise goes to 0, or this entire component goes to 0. And here it becomes 1 over 2. So in other words, a is a half. Then, since we still have 1 over 1 minus x, 1 plus x squared being equal to a half over 1 minus x plus bx plus c over 1 plus x squared, we can now multiply all these denominators on both sides. So we have 1 equals to a half 1 plus x squared plus bx plus c 1 minus x, which is equals to a half 1 plus x squared plus bx plus c minus bx squared minus cx. So what we're able to see is that we have constant, this constant here, and so we're saying, because on the left hand side we have 1, so we say 1 is equals to a half plus a half from this and this plus c, and therefore c is equals to a half. Now since the constant for x on the left hand side is 0, and we have c here being a constant for x, and we have b here being a constant for x, we can say that b minus c equals to what? To 0. And we know c to be a half, so b minus a half equals to 0, meaning that b also equals to a half. So in other words, our fraction is the same as a half 1 minus x plus a half x plus 1 over 1 plus x squared. Okay, and so we can go further and say that our integral of 1 over 1 minus x plus x squared minus x cubed is equals to a half the integral of 1 minus x plus x plus 1 over 1 plus x squared. Okay, which we can even expand to make three different fractions. So we have integral of a half x over 1 plus x squared plus a half, so there's dx here, integral of 1 over 1 plus x squared dx. So from here we can clearly see that this is negative a half, an integrated natural logarithm of 1 plus x plus a half. We can see here it's a half natural logarithm of 1 plus x squared, because when you differentiate 1 plus x, you get 2x. Since we're missing the 2x, the 2 on the numerator here, we had to assume that there was a constant half there. And then we have plus a half. This is a very famous integral. When you integrate that, you get the arctangent of x. Then we have an integration constant. So in other words, we have negative a half natural logarithm of 1 minus x. We have a quarter natural logarithm of 1 plus x squared. We have a half arctangent of x plus c. I think that is it. We could as well just say, okay, let's simplify this further. So we have a half and we push a half up so that this becomes the square root of 1 plus x squared plus a half arctangent of x plus c, and this becomes a half log of square root of 1 plus x squared over 1 minus x plus half arctangent of x plus c. So in other words, our integral 1 minus x plus x squared minus x cubed is equals to a half natural logarithm of the square root of 1 plus x squared over 1 minus x plus half arctangent of x plus the integration constant. Ladies and gentlemen, that is our answer. So thank you. Till next time, I hope you have a good time. Bye-bye.